Okay, how's everybody doing today? Okay, doing well, doing well. Okay, so the big reminder, tomorrow we have an exam, which is going to cover number sets, significant figures, scientific notation, and then also the lesson where dominantly we were talking about error approximation, remember absolute, relative, and percentage. It also included, interval notation. We had some conversions on there, Celsius to Fahrenheit and back again, different units of measurement we were converting. So all of that is fair game. And before I go ahead and forget, I will go ahead and tell you that it was on the assignment, but I don't remember anybody asking about it. You remember the problem, let me go ahead and give myself a little room here, where we had some kind of repeating decimal, like maybe 0.343434, dot, 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 and you were asked to go ahead and write that as a fractional value. Do you guys remember a problem like that being on the assignment? Okay, I did put one of these on the test. Do we remember or have a strategy for making that fraction, or do we need to kind of talk about it? Okay, so what I go ahead and do, and there's going to be different strategies that you can use on this, but I go ahead and say whatever value I'm provided, I'm going to go ahead and start off by saying, okay, let this equal x. All right, now the number of digits that are going to repeat, I'm going to go ahead and move the decimal place over that number. So in this case, it's just 34 over and over and over again, right? So I'm going to go ahead and move it over twice, so 34.34, 34, and then that's going to continue. But I'm going to set this equal to 100x. Okay. Now I'm going to set it equal to 100x because what would happen if I divided by 100? Yeah, the decimal is going to go back to where it originally was, right? So basically, the number of digits that are repeating is going to determine what this coefficient is. If there's only one digit that's repeating, I would multiply by 10. If there were 3, I would multiply by 1,000, and so forth. Now, what I would do is break this number apart at the decimal. So 100x is equal to 34 plus the 0.3434 repeating, right? But I started the problem by saying that x equals the original number, so I'm going to replace it. So 100x is equal to 34 plus x. And see, now it's just a simple, two-step equation. I'll go ahead and subtract the x over. 99x is equal to 34. Got 99 problems, but math ain't one. Okay. And then I get x equals what? X equals 34/99. And then, of course, if it can simplify, we want to go ahead and do so, okay, if there's any common factors. All right. But there we go. And there's going to be other strategies that you can use. That's just the one that I was taught and that I use most often. Okay. Does that make sense? We're good to go. Has anybody gotten their note cards ready? Few folks, okay, so you still have time if you haven't done so. I mean, take advantage of it. It has been a while since we've talked about this. It's been definitely more than a week because last week was the class time for the internal assessments. How are those going, by the way? Great. Okay. So really, how many weeks away are we from our rough draft being turned in? Well, we had 3 because we have this week for Thanksgiving, and it's the second week we return. The second week we return. And everybody's aware that the week we return is a short week. You only come Monday through Thursday. Okay, you have that first Friday off. So that's nice. Okay. All right. Well, I just wanted to go ahead and make sure that you were aware of that. Any questions on that test tomorrow? All right. The only thing I'm planning on doing Friday is I'm going to pass back the tests, talk about any questions we might have. Now, we did get the assignment earlier in the week, so I would say if you're able to get it to me this week, I'll go ahead and give it to you at the points in the bank, because officially I was looking for that on Friday, but somebody was telling me that on Friday all of the junior IB students are going to Tech. Okay. And is there anybody who's going to be missing tomorrow? I don't know if it's those out there because of the art. Okay. All right. So a few other folks. Okay.
Some people except me.
Okay. Okay. All right. Well, we'll see how that turns out. Okay. Well, what have we been talking about this week? Arithmetic sequences and series. And we've been learning how to find the nth term, and we've been kind of, using the formula in different ways to find different values, or even the common difference. That's the value that I add and subtract continually to generate this sequence. And we were talking about series yesterday after I showed you several technological ways to go ahead and do sequences. I think we got to... Yes, we had just gotten to this one right here. Now, a series is when you start taking a certain number of terms from a sequence and you just add them up. So we were on this problem here. I know there were several people who were super excited yesterday to come on up to the board and help me out with this one. Okay, I can tell by looking at you. Okay. So a new business is selling home computers. They predict that they will sell 20 computers in their first month, 23 in the second, 26 in the third month, and so on, in arithmetic sequence. How many months will pass before the company expects to sell their 1,000th computer? Okay, so I'll tell you what, if I can get somebody up here just to go ahead and help me find the equation. Okay, remember yesterday I mentioned that it turned out to be a quadratic. Okay, and I'll go ahead and take it from there. I just need to get to the quadratic. Okay, a lot of volunteers. Lucas, you look pretty excited to come up here. You got a smile on your face.
I don't know about that.
I'll even go ahead and start it for you.
Yeah, that would be awesome.
Okay, hey. As long as he's willing. There we go. All right, so you can actually go ahead and use either of the formulas we had for the sum of a certain number of terms. We were looking at two of these yesterday. I would probably just go off the very first one, S sub n. So S sub n is equal to the number of terms divided by 2 times twice the first term plus the number of terms minus 1 times the common difference. Okay. And I would just go ahead and kind of set it equal to 1,000 and then go from there.
Okay.
Is that good enough?
Well, I'm a little confused.
You're a little confused? Okay. So how can I help you?
What are you referring to by a term? Are you referring to like the number of computers you're selling? Like.
Well, not the number. Now, we want to know how many months it's going to take to sell their 1,000th computer. So the term number is the number of months in this case. So, for example, in the first month, they sold 20. Second month, they sold 23, and so on. So we're wanting to know how many months is it going to take where we reach a sum where we have 1,000.
I understand that part.
Okay.
After that.
Okay, well, let's just go ahead and start to plug in. Like, we don't know what n is. That is what we are trying to find. But we do know the other items. Oh, thank you, Jacob. All done?
Yes.
Oh, wow. Okay. There you go, sir. Okay, so I'm going to let Lucas take it from here. Oh, and Lucas, do you want the... Sure? Okay. You at least want to say hello?
Hello.
There you go. Hopefully they heard that.
Okay. So what would I take and divide it by 2? Would I just take like number 20 or 20?
Well, see, remember, n is the number of months, and that's what we're trying to figure out. How many months will it take before the total of all the computers sold will equal 1,000? So we're trying to solve this for n. Okay, so what is the value of u sub 1? 20. Okay, so that's the number of computers sold in the first month. And then do we know the common difference? D.
3.
It is 3. Just increasing by 3. Okay. So let's plug in everything we know and we'll start simplifying that equation. Well, now we have the formula here. We just need to go ahead and plug in what we know. So we don't know n, so I'd go ahead and leave the n over 2 for right now.
Okay. I'm so confused. I'm so sorry.
That's okay.
All right.
You're doing great.
So what am I dividing? I don't understand.
Well, you're not dividing by anything yet. So we know this one, and we know this one.
Okay.
So we just need to rewrite this, first substituting in the values that we know. And then we can go ahead and start simplifying the equation. Does that make a little more sense?
Yeah, so I would just put n and then divide by 20.
Well, not by 20. Because the formula starts off n divided by what?
23.
Oh. No, after the s sub n. See, which we already plugged in the sum of 1,000, so n divided by 2. And then times.
23 or?
Now remember, you said the first term was what?
3 or 20.
20. So what do I get if I double that?
40.
40. Okay. And then we'll just continue plus. And remember, we still don't know n, so we have to leave that binomial the way it is. Times what? What was the common difference? 3. 3 additional computers every month. Okay, and now let's go ahead and start to simplify this. Like, what can I do within the brackets?
Multiply these.
Okay, you can multiply through.
Yeah. Or would that not work because it's a variable?
Well, it's still a variable, but we want to go ahead and get it to a place where we can solve for n.
Okay.
So we know we're trying to get a quadratic out of this one. Okay, so who wants to help him out? Where can we go from here? John Henry, what do you think?
Oh, I don't know, but I do want to help him.
Okay, you mean actually physically come up here and help him? Oh, okay. Teamwork.
Yes.
Okay, we can distribute.
Distribute. Distribute that thing to the other thing.
So that thing to the other thing.
Yeah.
There's a lot of things up there. Which one are we talking about?
Yeah.
Okay. So that's right. We can do that. Now divided by, we're going to multiply it through. There we go.
Yeah, yes, 3.
There we go. Now let's close the bracket on that. On the far end, I'm sorry, on the right. And now what's also contained within the bracket that we still have to look at?
40.
40. Okay. So let's put the open bracket and then put the 40 plus. You see what I mean? Okay. So the open bracket, we'll go ahead and put that right here, and then we'll go ahead and put the 40 plus. Because you distributed,
40 plus.
yes sir, 40 plus that 3n minus 3. There we go. Let's go ahead and put that in brackets. Good, good, good. Now, what do I still have on the outside?
The 2.
Okay, n divided by 2. Okay, so let's go ahead and write the rest of what I got. So the n divided by 2 is in the front of the bracket, and the whole thing should equal. Okay, good. And what should it equal? It equals 1,000. There we go. Now, something I would probably go ahead and do here, I'd go ahead and get rid of that fraction, the n over 2. How can I get rid of him? I can just multiply through by what? 2. If I multiply through by 2, no longer a fraction, I can just distribute that in. Does that make sense? Okay, so let's do this. So I'm going to take this whole equation now, and I'm going to multiply by 2. With what? Holy equation. Ah. I was like, huh? Okay, so here we go. So we got rid of the 2, and we're going to distribute the n. So good, good, good. 3n squared. Minus 3n. There we go. Because that 3 would have the n distributed to it as well. Okay. So now we're almost there. What would 2,000 now equal when I combine like terms? Okay. Well, let's start here. Let's go ahead and write out my 2,000. Well, on the right side, you're going to have like pairs, like terms. Okay. So let's start writing my equation. Let's go ahead and put 2,000 equals. What can I combine the 40 in with? Just the negative 3n. Okay, so what's 40n minus 3n?
It's 37.
There you go. 37n, and then plus what? What's the last term we have there?
Oh, negative 3.
Oh, now we already took care of the minus 3n,
3n squared.
the 3n squared. And is that added or subtracted? That's added. And there we go. We got a quadratic.
All right, cool. Thank you.
Okay, good job. Good job. Yeah. All right.
Woohoo! Go Lucas.
All right. Good job. Good job. All right. Now I'm going to go ahead and rearrange the terms here. I like to have everything on one side. So I'm going to go ahead and say 0 equals, we got the 3n squared plus the 37n, and then we have the minus 2,000 because I went ahead and subtracted it over. Okay. So how many people were able to work it down to this quadratic? Okay, that's good. That's good. All right. So now from here, it is just basically whatever method you want to go ahead and use to solve the quadratic. Completing the square, that's probably going to get a little interesting because of the 3. We could use quadratic formula. You guys remember that? You don't remember that quadratic formula? Well, let's talk about the quadratic formula then. Now here I'm using n, so I'll just go ahead and say n equals. We have a, b, and c. Does anybody remember what it is? There we go. That is the quadratic formula. Okay. In fact, yeah, how many people were taught that by singing? Yeah, I was the same way. Okay. All right, but this is a great method because if you have your A, B, and C, it's just substitution. Okay. So I'm going to go ahead and plug everything in here. First off, the opposite of B, so that would be negative 37 plus or minus the square root. Well, then I would have B squared, 37 squared, minus 4 times A times C, okay, all divided by 2 times A, so that would give me 6. There we go. In fact, does anybody remember, and we're going to be talking about systems and quadratics about a week after we get back from Thanksgiving. Does anybody remember what we call the expression below the radical? That is the discriminant, yes. You can use that to predict how many solutions your quadratic is going to have before you start. By that I mean how many times it crosses the x-axis. Okay, so let's see what this actually turns out to be. Let me go to my calculator here, if it'll let me do it. Control divide, so I had a negative 37. Let's do the plus first. Square root, let's see, it was 37 squared. Whoop, it's outside. Okay, 37 squared. Then it was minus 4 times A times C. Okay, and then this was all divided by 6. Okay, so here we go. So I got this one, 20.379. And then here's a neat little trick you can do if you weren't aware. You could use your touchpad to go ahead and highlight this because we know we have 2 answers due to the plus and minus. So if I highlight that, it'll put everything back the way it is, and now all I got to do is change. Hey, don't you dare. You see it started erasing that. That was weird. Or at least I thought it was weird. Okay. All right. And there we go. So now we don't have to retype the entire thing. So I got negative 32.7. So graphically, this is where my function is going to go ahead and cross the x-axis, or I guess the n-axis in this case. Is there one answer that I would probably go ahead and get rid of? Yeah, because with the scenario we're in, the n represents the number of months, and we're not looking at a negative number of months. So it has to be 20, let's say 0.4. Okay. So it's going to take about 20.4 months for them to sell their 1,000th computer. How many people got that right? A few folks, okay. Was everybody else on the right track? Okay, close. Now, if you're interested in the notes, I did go ahead and solve it using the other formula. This one here where you take n divided by 2 times the sum of the first and the last terms. So there is a different strategy on the notes if you want to take a look at that. Okay, and here we go. Our last topic for this lesson, sigma notation. So this symbol here, sigma, that represents summation. So whatever you see here, you know you're going to be adding a bunch of terms together. So one example has already been given to you. It says, I want the sum starting from the first term to the fifth term. So the lower value is the term number you want to start with. The upper value is the term number I want to stop with. And what follows is the expression that would generate that sequence. So you'll notice when I equals 1, 2 plus 1, then 2 plus 2, 2 plus 3, 2 plus 4, all the way to 2 plus 5. So I went from the first term to the fifth term, and I just took the total of all of those. Okay, so in mathematics, that's what we like to use sigma for. It's our summation. Okay, come on in. All right. So for this one right here, let me go ahead and do this one by hand first. So I want to go from the first term to the fifth term. So the first term would be found by taking 5 plus 2 times 1, right? Plus, and then I would just continue down the line. 5 plus 2 times what? 2, because that would represent the second term, right? Okay, because this is the first, this is the second, and then I'm going to go to the third, so it'd be 5 plus 2 times what? There you go. 5 plus 2 times 3. See, I'm just going from the first term, in this case, to the fifth. Okay. So I'm going to say plus 5 plus 2 times 4, and then plus 5 plus 2 times 5. Okay. Yes? 5's on the top example. Oh, because this one's a different example. See, this one, this is what generates this sequence. 2 plus I generated the one that was already done for me. Oh, is that where you were confused? Okay, good. Okay, well, let's just go ahead and simplify this. So this would be 5 plus 2 plus 5 plus 4 plus 5 plus 6 plus 5 plus 8 plus 5 plus 10. All right. And if someone will help me get a grand total of that, what am I looking at? I got 55. And there we go. 55. Now, just a few things I want you to go ahead and be careful about. If you're going to use this particular type of notation, you want to be careful because sometimes you might be asked to work backwards like we have in other examples and find different items, like maybe even the number of terms. So if I were to go ahead and do this, let's say I gave you a summation, and let's say I started from, and it doesn't matter what variable you use, you might see some resources use K, some might use X. X is usually the most commonplace. So let's say we go from the third term, and I want to go to, say, the ninth term. Okay. How many total terms will I be adding up? Okay, it is what? It is 7. It is 7. See, we're starting with the third term, and I want to go to the ninth term. What a lot of people tend to do is they'll just go ahead and subtract the upper minus the lower. So they'll say 9 minus 3 is 6. But if you actually do that, you're going to subtract off the very first term that you're wanting to start with. So there's a pattern here. What you're going to do is take the upper, you're going to subtract the lower, and then you're going to make sure to add 1 at the end. So you always have the correct number of terms. Okay. So here, if I were to say 9 minus the 3 plus 1, that's going to give me 7. And if you were to go ahead and look at the sequence, you know, whatever it creates, 3, 4, 5, 6, 7, 8, 9, see, there are indeed 7 of those. Okay. And it's really easy to forget that. Is everybody okay? Okay. All right, well, let me go ahead and show you this in the calculator. And then I believe that will wrap it up for this lesson. Okay, so if I go over here to the calculator, and let's say I use this problem right here that we were just looking at. Okay, so from the first term to the fifth, and we have 5 plus 2i. Okay, so calculator, let me go ahead and document B out of here. Now, what I'm going to want to do, once I'm on my scratch pad, if you go to this button right here between 9 and your catalog, We've actually used this button before several times, once with chi-squared when we were looking for the matrix templates. But this button right here, what I'm looking for is that sigma notation, and it's right here. And there's going to be several other ways to find this on the Inspire, but I think this is one of the fastest. So when I click it, all I got to do is just fill in everything I have. So like in this case, let's say I wanted to start with the first term, and I want to go to the fifth term, and then I believe, what was it? 2 plus I? Okay. Is that right? Or let's go ahead and do the one we worked together, 5 plus 2i. Why not? Okay. 5 plus 2, and we just have to keep the variable constant. Okay. So I want to go from the first term to the fifth term using this expression. And see, it automatically takes the sum total of those terms. Gave me the 55 that we found by hand. Okay. And that's it. Any questions? Anybody having difficulty with any of the concepts we brought up in this lesson? Okay. When's the homework due? Okay, by Friday, but if you get it to me anytime, by Friday, I'll go ahead and give you the points. Okay. So if you are going to be absent, think about getting it turned in early. You can turn it in after the break, but I'll take a look at who was here and who wasn't. I think that's all I have, unless anybody has any other questions. Okay. Good.